Welcome back, listeners, to another exciting episode of Operating Systems Crashcast. I'm Victor, and with me as always is the brilliant Sheila. Today, we're diving into a crucial aspect of operating system development, debugging. Sheila, why don't you kick us off by explaining why debugging is so important in the context of operating systems?
Absolutely, Victor. Debugging is absolutely critical in operating system development. Unlike application-level bugs that might crash a single program, operating system bugs can bring down entire systems, affecting countless users and potentially causing data loss or security vulnerabilities. Just imagine if a bug in the memory management system allowed one process to access another's memory space. It could be catastrophic.
That's a great point, Sheila. The stakes are indeed much higher when it comes to operating system bugs. Can you walk us through the different types of debugging we encounter in OS development?
Certainly. There are primarily two types of debugging in OS development: source-level debugging and kernel-level debugging. Source-level debugging is similar to what application developers use. It involves stepping through the source code, setting breakpoints, and examining variables. Kernel-level debugging, on the other hand, is more complex and involves debugging the OS kernel itself, often requiring specialized hardware or virtual machine setups.
Interesting. So, kernel-level debugging sounds more challenging. What are some of the tools and techniques used for this type of debugging?
Great question. For kernel-level debugging, developers often use specialized debuggers like KGB for Linux or WinDBG for Windows. These tools allow developers to pause kernel execution, examine memory and registers, and step through kernel code. Another common technique is using print statements or logging mechanisms within the kernel to track execution flow and variable states. Some operating systems also support core dumps, which capture the entire state of the system when a crash occurs, allowing post-mortem analysis.
Those sound like powerful tools, but I can imagine there are still significant challenges in OS debugging. What are some of the main obstacles developers face?
You're right, Victor. OS debugging comes with its unique set of challenges. One major issue is reproducibility. Some bugs only occur under specific hard-to-replicate conditions. Another challenge is the real-time nature of operating systems. Pausing execution for debugging can change system behavior, making some bugs disappear or new ones appear, a phenomenon known as the probe effect. Additionally, debugging low-level components like device drivers or interrupt handlers can be particularly tricky due to their close interaction with hardware.
Those are some serious hurdles. It reminds me of the famous case of the Therac 25 radiation therapy machine in the 1980s, where a race condition in the operating system led to patients receiving massive overdoses of radiation. It really underscores the importance of thorough debugging in critical systems.
Absolutely, Victor. That's a chilling example of the potential consequences of OS bugs. It's why techniques like formal verification and extensive testing are becoming increasingly important in OS development, especially for safety-critical systems.
Speaking of testing, how does performance monitoring fit into the debugging process? It seems like ensuring optimal performance would be crucial for an operating system.
You're spot on, Victor. Performance monitoring and tuning are integral parts of the debugging process. Operating systems often include built-in tools for monitoring system performance, like the Task Manager in Windows or the Top Command in Unix-like systems. More advanced tools like DT-Trace or Perf on Linux allow developers to dig deeper, profiling system calls, measuring CPU usage and identifying bottlenecks. This data is crucial not just for fixing bugs, but for optimizing the overall system performance.
That's fascinating, Sheila. It sounds like OS debugging requires a wide range of skills and tools. For our listeners who might be preparing for interviews or considering a career in OS development, what would you say are the most important things to understand about OS debugging?
Great question, Victor. I'd say there are a few key points to remember. 1. Understand the difference between user space and kernel space debugging and the tools used for each. 2. Be familiar with common debugging techniques like logging, core dump analysis, and using hardware-assisted debugging. 3. Recognize the unique challenges of OS debugging, such as reproducibility issues and the probe effect. 4. Understand the importance of performance monitoring and profiling in OS development. 5. Be aware of the critical nature of OS bugs and the importance of thorough testing and verification.
Excellent summary, Sheila. As we wrap up, it's clear that operating system debugging is a complex but crucial field. From ensuring system stability and security to optimizing performance, debugging plays a central role in OS development. We've covered a lot of ground today, from the types of debugging and tools used to the unique challenges faced by OS developers. Remember, listeners, when you're using your computer or smartphone, there's a team of dedicated developers working hard to squash bugs and keep your system running smoothly.
Absolutely, Victor. And for our listeners, whether you're a budding OS developer or just curious about how your devices work under the hood, understanding these concepts can give you a deeper appreciation for the complexity and importance of operating systems. Thanks for tuning in, everyone.
Thank you, Sheila, and thank you to all our listeners. Join us next time as we continue our journey through the fascinating world of operating systems. Until then, keep exploring and stay curious.